All right, let's look at an exponential function. So, a couple of things that you sort of should be able to see from the function that is given to us is that this plus 3, just like we've seen this with hyperbolic functions or quadratic functions, is that that's a shift up 3. So this shift up 3, what that means is that because the exponential function itself has a horizontal asymptote, that means that the new horizontal asymptote is going to be at 3. The other thing that you should be able to look at is this 2 here, and that tells me that it's a growth function, so the thing should go up, and then there's a shift here. So, but keep in mind that when you tie a shift to an x like this, really think of it this way. It's an x minus 2. So the shift here is actually an x equals 2 shift, so that is a shift right. We're going to shift our normal exponential function. We're going to shift it right 2 units. Okay, now I don't want to graph this completely with transformations, but I think this is important to keep in mind for when I do the graph and for when I make my table, especially this last one. Okay, normally I would use a -1, 0, and 1 for an exponential function, and that works great for like a 2 to the x or a 3 to the x or whatever. But because of this -2, that means I will want to shift everything 2 units to the right. So I don't want to use a -1, 0, and 1. I want to add 2 to each of these values. So if I add 2 here, then that should actually be my 2. So 0 just became my 2. And then a -1 plus 2 is 1. So that saves me a little bit of erasing. And then 1 plus 2 is 3. And this is why they say it's a shift 2 to the right. Because now when I plug in that 2, I get 2 minus 2, which is an exponent of 0, and anything to the 0th power is 1, so 1 plus 3 is 4. Okay, so that's a number that I can definitely graph. If I use my 3 here, I get 3 minus 2 is 1, and 2 to the first is just 2, and 2 plus 3 is 5. So those are going to be 2 good dots. And then this is sort of that awkward dot in that you get 1 minus 2, which would be a negative exponent. And keep in mind that negative exponents don't have anything to do with negative values. So that's actually a half plus 3. So that's at 3.5. Okay, now that may not look like a function that is going to work out. So let's go ahead and graph what we have at this point. So at this point, we have a couple of values, and we have an asymptote. So if you have an asymptote, it usually makes sense to graph your asymptote before you start plugging in the points. Because a lot of times the asymptote sort of gives you an idea of what the shape of the function is going to be. So there's the asymptote at y equals 3. I forgot to label that. So that is a horizontal asymptote. And now let's plug in some dots. So at 2, I'm at 4. So I'm just above it. At 3, I'm at 5, so that's 5. And then at 1, I'm at 3.5. So this is where the function is starting to go towards the asymptote. So this is why I think it helps to have that asymptote, because you can use it to make the graph come out nice and pretty. So I'm going to cheat and say that the dot should have been there. And then this is what your exponential function should look like. Okay? It approaches 3, it never quite gets there, and then once it passes this 2, it starts to go up pretty fast. Okay? Hope this helps. Thank you.